Hello everyone. Today we want to learn about the single factor experiments. Basically, we want to know that we learned a little about single factor experiments before. Right now, we want to know that what's going to happen when we have blocking in our single factor experiment. So let me share my screen with you. Okay. Awesome. So here are our learning objectives. We want to understand the meaning of the blocking and the nuisance factors that we have. We want to learn about the randomized block design, or we can write it down as RBD as well. And we want to understand the extension of the ANOVA table when we use the RDB. And ANOVA table is the same as like analysis of variance table, like the same table that we had before. We saw that in chapter 4 a little more about the ANOVA. Like we learned about it, like for example, what's going to happen between the treatment and like within the treatments when we are working with ANOVA. Just make sure that you're going to review those before jumping to the blocking, because it's very similar. So blocking is a technique for dealing with the nuisance factors. And when we say these factors, there are factors that probably has some effect on the response, but we are not interested in them, on those factors. However, there are variability transmits to the response that needs to be minimized. So we need to deal with them, but we are not interested. I'm going to show you a few examples of it. And then typical nuisance factors, there include the batch of raw material, operator, piece of test equipment, time, shift days, like shift days that we have, different experimental units. Many industrial experiments involve blocking, or sometimes when we want to deal with these nuisance factors, we would need to add a blocking to our experiment as a person who designed the experiment. Failure to block is common flaw in design and experiments. So the consequences is that you don't consider you can think about it, what will be the consequences, but most of the time is that there is a factor that you don't block it and you don't consider it, or you don't consider it. Just think about the amount of the error that it can cause in your experiments and your results. If the nuisance variable is known and controllable, we use blocking. These are principles. If it's known and uncontrollable, sometimes we can use the analysis of covariance to remove the effect of these type of factors from the analysis. If so far it was known, controllable and uncontrollable, but if the nuisance factor is unknown and uncontrollable, like for example, Lurkin variable that we would have, we would hope that the randomization balances out the impact across the experiment. So block is the specific level of the nuisance factor, as I said. In general, a complete replicate of the basic experiment is conducted in each block. It's like that you would say that, like I believe in like 1 or 2 slides, I'm going to show you an example and you will see. It's like that you're going to, when we say replicate, it's like that you're going to do the whole experiment. But for example, if you want to measure something, you're going to change a small, like let's say a tip of your machine. But you're going to do the experiments from 0 to 100. So that we call it replicate. So a complete replicate of the basic experiment is conducted in each block. A block represents the restriction on randomization. All runs within a block or randomized. So here is an example. As I said, a number of metal samples could be randomly selected. Suppose we wish to determine whether or not 4 tips produce different readings on a hardness testing machine. So we have a hardness testing machine, and if you have seen that before, is that all of them, they have a tips. Like, let's say we are dealing with the ones that they are more common and they have tips on them, and then with those tips, they're going to measure the hardness of the sample that we have. So we're going to have 4 different like materials or 4 different tips that we would have. On a hardness testing machine, experimenter has decided to obtain 4 observations on Rockwell CS scale hardness for each tip. So if you pass the, we have a course, material science for engineers. So in that one, we were working on these tests together. If you pass that with me, probably we did an experiment on this. Okay, so there's a problem. If the metal coupons differ slightly in their hardness, the experimental unit will contribute to the variability observed in the hardness data. So that's the problem. Now look at here. So this one is like that, we can visualize it better. So the here is the test coupon, and we have the, like we would say, we said we have 4 tips, right? So each of these tips is going to be one block for our experiment. Like we would say that block number, like the here is like we have the combination of these tips for our like block. So number 1 is that tip number 3, tip number 1, tip number 4, and tip number 2. Like block number 2 is going to be like the test coupons that we have. It's going to be tip number 3, tip number 4, tip number 2, and tip number 1. So you can see that how is the sequence of them. And we have like 4 tips for it. And notice the two-way structure of the experiment. Once again, we are interested in testing the equality of the treatment means. But now we have to remove the variability associated with the nuisance factors, like with the block.